Okay, today we're going to learn about the real number system. Okay, the real number system, you're going to need some materials. And if you don't have them, that's fine. You can use just a pen or a pencil. You're going to need a page from your notebook or a piece of paper that you will be using for your notes. Either colored pens, markers, or pencils. And if you don't have them, like I said, you can use the pen or pencil that you do have. The colors will just help you to differentiate between the layers that we're going to see in the real number system as we put this on paper. So you can pause this right now, go get your items, and then come back. All right, on your paper, I would like you to make a box all along the edges of your paper, as far out as you can go without going off the page. Now I did my first one in black, a big giant box, okay? A rectangle there. Okay, the real numbers are our first category that we're learning about, okay? And the real numbers are all the numbers that we know. So what you want to do is in the top left corner of your paper, within that box you've created, is write the words real numbers and the definition. It's everything we know. It's fractions, decimals, symbolic numbers like pi, numbers we don't like to calculate with, and numbers we do like to calculate with. Within real number system, we have two categories, two subsets. So the first subset, as you can see, I've done in blue. Okay, we'll name it in a minute. Doesn't go through the whole page, so you want to leave some space here in the bottom. Okay. So the numbers that we're going to put in here are called rational numbers. And you can pause at any time to write down the notes that you need to write down. Okay, and you should write everything that I have on here. And rational numbers are numbers that can be written as a fraction. They're terminating or ending decimals, decimal numbers that stop, or special cases or repeating decimal numbers. So let's go for the repeating special case, okay, repeating decimals. 1/3 is a common fraction that we know, and we also know that it's unique in that it's 0.333 and repeating. And as you can see, I have the repeating bar on here. That 3 will continue indefinitely. So although this decimal does not terminate or end, it is a special case that can be written as a fraction. So therefore, it's a rational number. 2 is a rational number. Its decimal is 2.0, or it can be written over 1, which makes it written as a fraction. 6.9 is another rational number. It is a terminating decimal, a decimal that ends. Negative 713, okay, it's a negative number this time. That's also a rational number. Okay, and 117/25, which is a fraction, is a rational number. The other number set that we have within the real numbers, but is not rational, is something called the irrational numbers. So draw yourself another box in another color if you can, down below the rational numbers, but within your real number page. And those are irrational numbers. And again, you can pause at any time to write the notes and then start again to continue the lesson. Numbers that cannot be written as a fraction, those are irrational numbers. If I can't write it as a fraction, it is irrational. If I can write it as a fraction, then it's rational. So numbers that cannot be written as a fraction, symbolic numbers, numbers that are symbols like pi, non-perfect squares, and non-terminating, non-ending decimal numbers. So the first example, of course, of a symbolic number would be pi. It is 3.14 and it continues indefinitely. We approximate it, hence the squiggly equal signs, and we round it, usually to 3.14. Another example of an irrational number is a non-perfect square. Square root of 2 is approximately equal to 1.4, but it goes on indefinitely. Another example is a decimal. Even if it's very long, it could be very short, but it does continue. So you can see the 3 dots at the end of this number, and that means that it continues on. There's no pattern to this. We cannot write it as a fraction, so therefore it's a non-terminating decimal. These are examples of irrational numbers. Now, going back into our rational numbers, we have another subset of rational numbers. So draw yourself another box. I did mine in green. Okay, make it big enough to fit inside your rational numbers. And those are called integers. We are pretty familiar with integers, and we might not even know that that's what they're called, but they're positive numbers, 0 and negative numbers, but their denominator is always 1. Therefore, we do not see the number 1 in the denominator when we write it. An example of these are -2, -1, 0, 1, 2, and they both have the ellipsis on both sides, coming from the negative side, coming from the positive side. And that means that -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, etc., etc., etc. So it goes to infinity both on the negative and positive sides, but all those numbers are considered integers if they can be written over 1. Another subset of the integers within our rational numbers, within our integers, I drew out a box in pink here, are called our whole numbers. Whole numbers are a subset or a subcategory of our integer numbers. Okay, so they are integers and they are rational numbers, but they're their own unique set coming from rational and integers. And as you can see, integers here, our examples were -2, -1, 0, 1, and 2, and etc. Our whole numbers start with 0 and continue in the positive direction. So 0, 1, 2, 3, 4, etc. And lastly, we have another subset within the whole numbers, and I outlined those in purple. So if you would get your pen or pencil and outline those, they are called the natural or counting numbers. They are exactly as they sound. When we start to count, we naturally will start with 1, 2, 3, 4, and etc. So they are a subset of the whole numbers. They just don't include 0, so they're a set of whole numbers, but they exclude the 0. That's why they're not exactly the same as whole numbers. So that's our real number system. And now we can answer questions about what types of numbers do we have, and are these types of numbers the same as other types of numbers? So let's look at some examples. All right, first example. And again, put these in your notes, please. What type of number is 5? Okay, well, if we want to know what type of number 5 is, we need to go back to our slides here, our real number system slide. Okay, 5. Well, it's a real number because it's a number we know. The question is it rational or is it irrational? Well, 5 is a number that can be written as a fraction because you can put it over 1. It is a terminating decimal because it's 5.0. Okay, so it is not irrational, it is rational. So far we know it's real and it's rational. Now we jump into the integers. Is 5 an integer value? So we say, all right, it's coming -1, 0, 1, 2, yeah, 3, 4, 5. Yes, so 5 is also an integer. So 5 is a real number, rational, and an integer. Now let's jump into the whole numbers. Is 5 a whole number? Well, yeah, 0, 1, 2, 3, and so on. So 4, 5, 6. 5 is a whole number. And we jump into the natural or counting numbers. Well, can we count to 5? Sure. So 5 is natural or counting, whole, integer, rational, and real. So let's go back and see and get that in our notes. All right, so it's a real number, a rational number, an integer, a whole number, or a natural counting number. All right, what type of number is pi? All right, again, let's go back to our slide, pi. Well, pi is a number we know. We've used it often for calculating circumference of circles and area of circles. All right, so we know it's real. Is it rational or irrational? Well, pi is a symbolic number, so therefore it is irrational. And that's it. It can't be anything else. Once it's irrational, you cannot go into the integers, whole numbers, or natural numbers at all. So all we know about pi is that it is real and irrational. So those are the types of questions we're going to ask about specific numbers. Okay, now we get to the always, sometimes, never category of questioning, which is really something that confuses us. So we're going to hope we can get through how to think about these. The question is, are whole numbers rational numbers? Whole numbers, rational numbers. So let's go back to our real numbers, are whole numbers rational? All right, so let's go to whole numbers. Whole numbers are inside integers, which are inside the rational number category. So if these subsets are inside what we're questioning, then the answer is yes, they are. So are whole numbers rational numbers? Yes, they are, because whole numbers are contained within the rational number category. All right, so that would be and always. Whole numbers are always rational numbers. Next, are rational numbers whole numbers? Okay, again, let's go to our slide. All right, are rational numbers whole numbers? Well, rational numbers are the big category, and we have many categories within them, being one of them being whole numbers. But we want to know, is a rational number a whole number? Well, let's look at the types of rational numbers we have just in our examples. We have 2. Is 2 a whole number? Well, yeah. But is 1/3 a whole number? Well, no. So the only thing we can say is that if the question is showing that the grouping you're asking about is outside the category, you can say sometimes. Because we know 2 is a whole number, but 1/3 is not. So sometimes a rational number can be a whole number, but not always. Next, are irrational numbers natural numbers? Irrational. Are they natural numbers? Are they counting numbers? All right, let's go back to our real number system. Are irrational numbers counting numbers? Well, irrational numbers are not even part of the category that counting numbers are in, which are rational. So irrational numbers, once you know an irrational number, it cannot be natural, whole, integer, or rational. So irrational numbers, are they counting numbers? The answer would be never. Are integers whole numbers? All right, well, let's think about it. Let's go back to our slide. Integers, are they whole numbers? All right, so integers are -2, -1, 1, 2, 3, 4, 5, etc. And whole numbers are 0, 1, 2, 3, 4, 5, etc. So are integers whole numbers? Well, some of the integers are whole numbers, so the answer would be sometimes. Okay? So that's how you answer these questions. So as we go through the real number system, you want to keep your real number system page in front of you, your chart, so that you can answer the questions just like this, and you can come back and view this lesson at any time to help you to answer those questions.